Okay, picture this. It's 2 in the morning. You're out in the yard. It's freezing. The wind is just cutting right through you, and you're walking this long line of trailers.
The graveyard shift. We've all been there.
Exactly. And you're just hoping for a quiet night. You get to a reefer that's supposed to be humming, keeping a load of fish frozen solid, but silence.
Never a good sign.
And then you see it, that little orange light just pulsing. You get closer and you read the code. Alarm code 18, high engine coolant temperature.
The classic overheat. You know, it's funny. That's probably the one alarm that everyone, and I mean everyone, gets on a gut level. Your car, your truck, a $50,000 unit, hot is bad.
Right. My immediate thought is just, well, that's it. Game over. Engine's cooked. Load's going to be soup, and my boss is going to have my head. But looking at the tech manuals we've got here for this deep dive, it seems like my gut reaction is maybe a little off.
It's incomplete. That's the key. If you take one thing away today, it should be that code 18 isn't just a dummy light. It's not a simple switch that flips when the water gets too hot. It's actually the result of this surprisingly smart survival algorithm running inside the controller.
A survival algorithm. You make it sound like it's alive.
In a way, it is. The unit's constantly making a decision. It's weighing the survival of the engine against the survival of the cargo. It's asking itself, do I save the engine block, or do I push just a little harder to save the load?
So that's our mission today. We're not just going to say what code 18 is. We're going to decode that logic. We're going to break down how it decides whether to fight or surrender.
Exactly. We'll get into the retry routines, the safety protocols, especially the big one with the expansion tank cap.
We have to talk about that continuous restart setting. I saw that in the engineering notes, and I know that's a spicy topic for some fleet managers.
Oh, it is, definitely.
All right, let's start at the top. Code 18, high engine coolant temperature. The engine's too hot. But you're saying it doesn't treat all overheating the same.
Not at all. The second the processor sees that temperature cross the threshold, and that number is 220 degrees Fahrenheit or 104 Celsius, it doesn't just panic, it pauses.
It losses.
For a microsecond, yeah. And it looks for more information. It immediately checks a second sensor, the coolant level sensor.
Ah, this is the fork in the road they talk about in the doc.
Precisely. The unit asks itself one critical question. Am I hot because I'm working too hard? Or am I hot because I'm out of water?
Out of water meaning there's a leak somewhere.
Right. And that's scenario A. If the temperature is high and the coolant level sensor is screaming low, well, the debate is over. The unit sets an immediate shutdown alarm.
There's no hesitation there. Why not try to run for just a few more minutes?
It all comes down to basic physics. You can't cool a liquid-cooled engine with air. If the coolant is gone, the water pump is just spinning in air pockets. There's no heat transfer.
It's just getting hotter and hotter.
Exponentially. If it tries to run, you're not just risking an overheat, you're pretty much guaranteeing a seized engine, a cracked block, catastrophic failure.
So the logic is the engine is about to self-destruct, so the cargo doesn't matter anymore.
It's harsh, but yeah, a dead engine means a loss load anyway. The machine is just cutting its losses to save the expensive hardware.
Okay, that's the worst case path. But what about scenario B? The temp is high, but the coolant level sensor says, hey, I'm full.
Now this is where the unit gets clever. It knows it has coolant. It has the tool to remove the heat. It just can't get rid of it fast enough.
Like when you're sitting in traffic in Phoenix in July.
Perfect example.
Yeah.
Or the radiator's just clogged with dirt. The system is intact. So instead of a shutdown alarm, it sets what's called a prevent alarm.
Prevent? That's an interesting word. What is it? What's it preventing?
It is preventing a total shutdown. It's trying to find a middle ground to save both the engine and the cargo. It goes into this mode of temporarily reduced performance.
So it's like it throttles itself back.
Exactly. It'll say, okay, I'm hurting, but I can still do some work. It might lower the engine RPMs, maybe reduce the load from the compressor, anything to bring its own fever down while still keeping that trailer from warming up.
So here, it's prioritizing the cargo, but carefully. It's willing to run hot, but not dry.
You got it. But it's not a suicide mission. It has rules, what we call the two-strike rule.
Okay, walk me through that.
So the unit's hot, but it has coolant. Prevent alarm is active. It tries to run at that reduced power. If the temperature doesn't start coming down within a set time, that's strike one. It gives up on that first attempt.
But it doesn't lock out.
Not yet. It takes a timeout. And this is where you'll see another code pop up, alarm code 84.
Restart null. I saw that in the schematic.
Yep. If you see 84 with 18, it's the unit telling you, I'm in a mandatory cool down. The engine shuts off completely for a forced 15-minute break.
15 minutes. Man, if you're hauling ice cream, that feels like an eternity.
It does. It feels like forever to the driver. But the engine needs it to let all that heat soak dissipate naturally. After those 15 minutes are up, it tries again, wakes up, clears its throat, and starts the engine. That's attempt number 2.
Yeah, and if it overheats a second time.
Strike 2, you're out. If it can't hold a safe temp on that second try, the logic finally gives up. It converts the prevent to a shutdown. Unit is locked out. Call a mechanic.
2 chances. Seems fair.
Oh, yeah.
Now we get to that setting in the controller. Continuous restarts.
Ah, yes. They never say die mode.
If that's turned on, does the 2-strike rule just go out the window?
It does. With continuous restarts enabled, the unit will never ever lock out for high water temp as long as the coolant level is okay. But it changes its strategy.
Yeah.
Remember that 15-minute timeout?
Yeah.
In this mode, after it fails, that timeout gets extended to 60 minutes.
A full hour. It just shuts off for an hour.
Sits there dead silent for 60 minutes. Then it'll wake up, run until it gets hot again, which might only be 5 or 10 minutes, and then shut down for another hour. On and on.
I'm trying to figure out when that would be useful. An hour of downtime means your cargo temperature is definitely climbing.
It's a gamble. The idea is that, 10 minutes of runtime per hour is better than 0. You're banking on the thermal mass of the load. A trailer full of frozen chicken can hold its temp for a while. That little bit of runtime might just keep the air moving enough to stop the top layer from thawing.
So it's a desperation play.
Totally. It's the unit basically hoping that the situation changes. Maybe the sun goes down. Maybe the truck gets back on the highway and gets some airflow over the radiator. It's buying time.
And on the flip side, I saw you can disable restarts completely.
You can. 0 tolerance, 1 overheat, and it shuts down for good until a human comes and resets it.
Seems risky for the load.
It can be, but imagine you're hauling sensitive pharmaceuticals. Any temperature deviation is a huge problem. You might actually prefer it to just shut down and send an immediate critical alert rather than, limp along and give you a false sense of security.
That's a really good point. The limping could mask how bad the problem really is.
Okay, so what if the driver makes it to a depot, plugs the trailer into shore power, electric mode, diesel engine's off, does code 18 just go away?
Nope. And this trips up a lot of new techs. You plug it in, the electric motor kicks on, but code 18 stays on the display. Its meaning changes, though. It becomes a log alarm.
A log alarm, so what's the difference?
A log alarm is basically a note to self. The unit is running fine on electric power, but the controller doesn't want anyone to forget that the diesel engine is sick.
So it's a warning for the mechanic. Hey, don't unplug this and try to run on diesel until you've checked me out.
You got it. And there's another little detail here. On most of these units, the water pump is driven by a belt on the diesel engine. When you switch to electric, that engine stops turning.
Which means the water pump stops turning.
Right. So the coolant inside the engine block is just sitting there. It's stagnant. It can stay hot for a long, long time because it's not being circulated through the radiator to cool off.
So does the tech have to clear that cone manually? Usually not. It has an auto-clear feature in this case. Once the block finally cools down on its own, below that 220-degree threshold, the code will just vanish from the active alarms list.
It's handy. It cleans up after itself.
Yeah, it saves a trip up the ladder just to press a button for a problem that isn't really a problem anymore.
All right, let's shift to the hands-on part. I'm the tech. I'm standing in front of the unit, lights flashing. What do I actually do?
There's a very clear 5-step diagnostic procedure in the manual, and the order is important. You don't just start throwing parts at it.
Step 1 seems almost too simple. Check the engine water temperature.
Don't just trust the alarm. You need to go into the gauge menu on the controller and look at the live sensor reading. You're looking for a magic number, 220 Fahrenheit, 104 Celsius.
Why bother verifying?
Because sensors lie.
Yeah.
If the engine block feels cool to the touch, but the screen says it's 250 degrees, you don't have a cooling problem. You have a sensor or a wiring problem. Verify reality first.
Okay, fair enough. Let's say the gauge confirms it, reading 225. Step 2 is check the engine coolant level. And I feel like we need to just pause right here for a major safety announcement.
Yes, absolutely. If you're listening to this, stop what you're doing. Do not, under any circumstances, open the cap on a hot expansion tank.
We've all been tempted. Just a quick peek to see if it's empty.
And it's a terrible idea. Think about it. That coolant system is pressurized. That pressure is what allows the water to get up to 220 degrees without boiling.
Right. Pressure raises the boiling point.
So you have superheated liquid in there. The second you twist that cap, you release the pressure. The boiling point instantly drops back to 212, but the water is at 220.
It flashes into steam.
Instantly. An explosion of steam that expands to, like, 1,600 times its liquid volume. It's a geyser of boiling chemicals. It will peel the skin right off you. It's a life-changing injury.
So to be clear, on step 2, you check the level through the see-through overflow bottle. You look for puddles on the ground. You do not open the cap.
You do not open the cap until that engine is cool enough to touch. Period.
Got it. Okay, so we've checked the overflow. It's full. We know there's coolant. Step 3, check the water pump drive belt.
Mechanical 101. Belt turns the pump. Pump moves the water. If that belt is loose or broken, no circulation.
Add a quick check for that.
Just the tension test.
Buddy.
Grab it in the middle.
Yeah.
If you can twist it more than about 90 degrees, it's too loose, it's slipping.
Simple enough. Step 4, check the radiator for airflow restrictions.
This is the big one for nuisance alarms. What I call the plastic bag syndrome.
I see it all the time on the road. A grocery bag just gets sucked right onto the grill.
And it's like putting a piece of cardboard over it. It completely blocks the airflow. But look for other things too. Mud caked in the fins. Or, and this is a pro tip, look for bent fins from someone using a pressure washer too close. If the fins are flattened, air can't get through.
So how do you check that?
The flashlight test. At night, shine a bright light from behind the radiator through the engine compartment. If you can't see that light clearly from the front, it's clogged.
And you clean it from the back to the front, right? Push the dirt out the way it came in.
Exactly. Don't drive it deeper in.
Okay, we're at the end of the line. Coolant is full, belt is tight, radiator is clean, and it's still throwing code 18.
Now you move to step 5. You suspect the messenger. At this point, the manual actually tells you to go to a different procedure entirely. Alarm code 06, check coolant temperature sensor.
So we've ruled out the mechanicals, now we're blaming the electronics.
Pretty much. You'll unplug the sensor and check its resistance with a multimeter. There's a chart in the service manual that tells you what the ohms should be at a given temperature. If your reading is way off, the sensor's bad, replace it.
It's always a good day when it's just a $10 sensor. So we fixed the issue, we pulled the bag off the grill. How do we clear the code?
Well, you can do a manual clear right there on the controller, but there's also an automatic clear.
Right, we talked about that for electric mode.
It works in diesel too. If the unit was in that prevent mode, struggling along, and then all of a sudden the problem goes away, you pull the bag off, the temperature will start to drop. The controller sees that and says, oh, crisis averted. It clears the alarm itself and ramps back up to full power.
It forgives itself.
It does. It's designed to run. If the thread is gone, it wants to get back to work.
You know, my whole view of code 18 has kind of shifted during this. I always saw it as just a failure, a stop sign. But it's really more of a cry for help.
That's the perfect way to look at it. It's the unit telling you, hey, I'm trying my best to save this load in this engine, but I need a hand. If it didn't have this logic, if it just ran itself to death, our repair bills would be astronomical.
It's a warning shot, not a death sentence.
Exactly.
Before we wrap up, I want to go back to that continuous restart setting, the one with this 60-minute timeout loop.
The controversial one, yeah.
It leaves a really tough question for the people managing the fleets. Is that setting actually saving the load? Or is it just delaying the inevitable call to a mechanic? You know, you're getting maybe 10 minutes of cooling an hour in the Texas summer. Is that a real safety net? Or are you just slow cooking your cargo while the computer tells you everything's fine?
It's a tough calculation of risk. And it's a good reminder that sometimes relying too much on the automation keeps us from making the hard but correct call, which is to get a truck out there. The unit is smart, but it can't fix its own broken belt.
Something for the ops managers to think about. That's our deep dive on Alarm Code 18.
Stay safe out there, check your gauges, and please, for the love of all that's holy, keep your hands off that hot radiator cap.
We'll catch you on the next deep dive.